All right, so the last one for this section, let's do this one. It says, and it gives us a linear function, so it's pretty simple. And what we need to do is we need to calculate the average rate of change and percentage change for each of the following intervals. So we're going from x equals 1 to x equals 3, from x equals 3 to x equals 5, and x equals 5 to x equals 7. So basically we have to calculate those. So we'll say f of 1 equals, well, if we plug in 1 here, that's going to be 3 plus 4, that's 7. And f of 3 equals, well, 3 times 3 is 9 plus 4. That's going to give me, what, 13? And then we have f of 3, we already found it's 13. Then f of 5, let's see, 5 in here, that's 15 plus 4, so that's 19. And so then f of 5 again is 19. And then we have f of 7. So that's 21 plus 4, so that's 25. Okay. So now we have to do all the calculations. So what do we have here? For A, we have several AROCs and percentage change because we have to find the average rate of change AROC and the percentage change. So let's find AROC first. And so the AROC is going to be the f of 3, which is, well, let's write it out. So it's f of 3 minus f of 1 over the 3 minus 1, basically. And so that's 13 minus 7 over, and then that's just the 2. Okay. And so 6 divided by 2, that's going to give us 3. That's going to be our value. That's AROC. Okay. And we don't have units here, so it's just 3. Now, what about the percent change? Okay. So percent change, that's going to be equal to, and again, we take our f of 3 minus f of 1 all over now our f of 1 this time, and then times 100%. And so f of 3, we had 13 minus the 7 divided by the 7 times 100%. And this one I probably have to do on my calculator. And I get 85.714. So, and that's just percent. Okay. Then B, let's see if we can get B in here. B for the AROC. All right, let's just write it out, and we're just going to go straight to the numbers because we know it's going to be the 5 minus 3 over 5 minus 3. So f of 5 was 19 minus f of 3 was 13 divided by 5 minus 3. And so 19 minus 13, that was 6, divided by 5 minus 3 is 2, and so that's 3. Okay, so that looks good. Now, what is our percent change? Well, that's going to be f of 5, which was 19, minus f of that's 13 over, and then we have the 13 times 100%, and that's going to be approximately, and this one I'll have to do, so and that looks to be 46.154%. So 46.154%. All right, hopefully we have another page here. Now we have part C, and so that's 25 and 19. So we'll have AROC is 25 minus 19 over, and that was a 7 minus a 5. And so that's going to, well, we don't have to be approximate. That's going to actually give us a value. I don't think it's going to be a decimal. So we have our 25 minus our 19 divided by our 2, and it gives us 3 again. See? So now the only thing it's going to be is the percent change. And that's going to be our 25 minus 19 over. And here we have over the f of 5, which is the 19 times 100%. And this one will be an approximation. And times 100, that's 31.579%. So 31.579%. All right, so we've got all of them. And if we notice, the AROC is the same in all three. And our percent change is changing, it's going down as we go. So now it says, on the basis of the results in part A and the characteristics of linear functions presented in chapter 1, what generalizations can be made about percent change and average rate of change? So, our equation is going to have some kind of line that looks like that. And so what can we say about this? Well, we can say, and this is actually part B, but that was 8, 1, 2, 3, but we'll say this is B here. And so the AROC is the average rate of change between 2 points and is constant. Okay, because we always had 3. All right. But what do we see about the percent change? The percent change, not percent, that varies as we move to the right and or left. Because if we go left, we'll start seeing the same thing because it's a line. So and we're changing percents going this way, and we're going to change percents going that way as well. Okay, so depending on where we actually started, it's going to be basically varying the whole way. It's not going to be the same as we go, and that's because what's the percent change from here to here? That's going to be a smaller change than a change from here to here, even though it's we're going up by equal amount each time, but going from smaller number to bigger one, that's going to be a bigger change on the small end, but it's going to be a smaller change here on the big end. So that's why we're seeing that. All right, so that's all I have for this section.